Hello guys, welcome to my YouTube channel. So in this video, we are going to learn about the Kirchoff's rules and how we can use the Kirchoff's rules to solve such a problem. Now, Kirchoff has two laws that are used to solve this problem. We have the first Kirchoff law and the second Kirchoff law. So the first law says that the amount of current entering the junction in a circuit equals the amount of current that leaves the junction. Then the second law says that the amount of current the total sum of voltage, around a closed loop equals to 0. So we are going to use those two laws to help us solve this particular problem. Now, we have this loop here, we have this loop, then we have this bigger loop outside here. Then we know current always flows from negative to positive. So we are going to go around this closed loop, then we can choose either of these two loops so that we can have the three equations that will help us solve this particular problem. So, just as the first law says, it says that the amount of current entering a junction equals the amount of current that leaves the junction. So, if you come here, here's the junction. So, we can just name this I2, then I3, then I1. So, I2 gets into the junction, then it splits into I1 and I3. So that helps us generate the equation. So, I2 equals to I1 plus I3. That is our first equation. The second equation, we are going to go around this loop here. So let's choosing the bigger loop. So I'm going to move around this way. Then find the total voltage around that loop. So here we have 14 volt. 14 volt. Then we come here. Here we have a resistor. Then the amount of the current I2 is flowing through that resistor. So the current, before the current gets into the resistor, it has a high, Then after getting it is low because of the resistance. So we are going to put a negative sign because it's now low as compared to how it entered. So I'm going to say then voltage is equal to current times resistance. So our resistance is 4 ohms and current is I2. So negative 4 I2. Then I'm going to come this way, here we now have I3, current 3 that is flowing. So current 3 is going to come this way, flow through this resistance. Before it gets to the resistance, it is high, and the resistance is low. You can put the negative and the positive sign to get so that you may not get confused. So I3 is going to leave as a negative. So I'm going to say negative 2. The resistance is 2 ohms, so 2, and the current is I3. Then we get back to where we started. So that is our second equation. So the third equation, now that I've used the bigger loop, you can decide to use either this loop or this one. So I've chosen to use this one. So I'm going to go around this closed loop and find the total amount of voltage around that loop. So I'm going to start with the 10 volt battery. Then I come this way. So remember current 2 split into current 3 and current 1. So the one that is flowing inside here is current 1. So before it gets to the resistance is high, so you can put a positive sign. Then the resistance is low. So and the resistance is 6 ohms. So we want to put a negative 6I1. Then you are going to come this way. So remember I3 is flowing towards this side. Then I'm now doing my calculation coming this side. So I'm going against the current. So when I'm going against the current, I'll put a positive sign here and a negative sign here. So to me, I'm going to have now a positive sign. So plus voltage is current times resistance. Resistance is 2 ohms. Current is I3. So plus 2I3. That's our calculation. We are going to use these three equations to help us find the current or the total amount of current that is flowing throughout this particular system. So I'm going to use equation 2 to make I2 a circuit formula. So here we go. Negative 4 I2 equals to 2I3 minus 14 volt. Because I've got the equals 0, equals 0, equals 0. I've got the positive sign, the equal sign. So I'm going to divide by 4, by 4, by 4. So I2 is going to be half I3, negative, you have negative 4. So negative half I3, then negative 14 divided by negative 4. That is plus 3.5 volt. So that is the equation for I2. So I'm now going to use equation 3 because I did equation 2 to make I2 the subject. You can make any. I'm just choosing to use to make I2. You can just make I3. So in the next equation, I'm going to make I3 the subject of the formula. So 2I3 equals, so when this negative 6I1 to be 6I1 to now be positive, then minus 10 volt. So I'm going to divide by 2 by 2. So that equation for I3 equals, we have 3I1, then minus 5 volt. So this is the equation for I3. So I'm going to use these two equations, that is I2 and I3, together with this first equation to get the total amount of current throughout our system. So I2 is equal to I1 plus I3, and I2 here is the equation for I2. So it is negative half into I3, negative half I3, and I3 we have here 3I1 minus 5 volt. So 3I1 minus 5 volt. Then you close the bracket. So that is I2 equals I1. We don't have equation for I1. So equals I1 plus I3. The expression for I3, that is 3I1 minus 5 volts. 3I1 minus 5 volts. Now let's break the bracket. So this is the negative half into 3, that is the negative 3. So we are going to break the bracket. So negative half times 3, that is negative 1.5 I1, then negative half times 5, that's negative 5, that is plus 2.5 volt plus this 3.5 volt is equal to I1 plus 3I1 minus 5 volt. Let's now collect like terms. So we have I1 plus 3I1, that is plus 4I1. Then we have negative 1.5 I1. So we are going to bring this 4I1 this side. So it's going to be minus 4I1. So negative 1.5 minus 4. That is negative 5.5 I1 equals to, so we have 2.5 volt plus 3.5 volt. That's going to give us 6 volts. So when 6 volts cross this side, it is positive, so it's going to be negative 6 volts. That is turning up to negative 11 volts. So equals negative 11 volts. So let's divide negative 5.5, negative 5.5. So I1 is going to be negative 11 divided by negative 5.5. That is 2. So the unit for current is amperes. So 2 amps. So that is I1. So let us insert it in this equation and find all these other currents. So we have I3. I3 is 3I1 minus 5 volt. So 3 in I1, which is 2 minus 5. That is 6 minus 5. That is 1. So I3 is equal to 1 amperes. So I2 is equal to negative half I3, negative half, then I3 is 1, then plus 3.5. That is going to give us 3 amps. And we want to see if these values really show or the application of Kirchoff's rule in solving this particular equation. We say I2 is equal to I1 plus I3. So our I2 there is 3 amps is equal to I1, which is 2 amps, plus I3, which is 1 amp. then we are right. So we're just going to use this particular formula to solve any other solution that is presented this way. Remember to subscribe to my YouTube channel for more videos pertaining to academics. I wish you were at school and take legal academics. Thank you.